All right, let's just jump right in. We're going to go on this completely hypothetical voyage, right? We're talking a journey down layer by layer, straight into the very heart of our own planet. I mean, it's a trip no human has ever actually taken, obviously, but what's so cool is that science lets us picture it in incredible detail. So let's really think about that for a second. What if you could actually travel to the center of the Earth? What would you even see? How would it feel? That's really the big question we're tackling today, as we imagine descending through these totally alien landscapes of insane pressure and mind-blowing heat, and it's all happening right underneath our feet. Okay, so our journey kicks off right here on the surface. And, the very first thing we've got to get through is, well, the ground we're all standing on right now. This is where the impossible descent begins. We think of the ground as this huge, solid thing, right? But when you look at the whole planet, the crust it's like the skin on an apple. It's this impossibly thin outer layer. And what's wild is how different it is from place to place. Under the oceans, it might only be 10 kilometers thick, but under the continents, it can stretch up to 35 kilometers. It's basically this fragile jigsaw puzzle of tectonic plates that are always moving. So here's our roadmap for the trip down. First, the crust. That's a pretty quick one, relatively speaking. Then comes the big one, the mantle. After that, we hit the outer core, and finally, our destination, the inner core. The distances here are just staggering. I mean, look at those numbers. So yeah, let's get going. All right, we're through the crust. Now we enter the biggest and honestly one of the most mysterious parts of our planet, the mantle. And forget what you've seen in movies. This is not some giant lake of fire. No, it's something way weirder. This is one of those concepts that just kind of breaks your brain a little. The mantle? It's solid rock. But because of the insane heat and pressure down there, it acts like a liquid, but in super slow motion. The best way to picture it is like hot asphalt on a summer day. It's flowing, creating these huge currents over millions of years, and that's what's actually pushing the continents around up here. Okay, so try to imagine actually being there. The pressure is so immense, it would just pancake a block of steel in an instant. Temperatures are soaring past 3,000 degrees Celsius. The rock itself is changing. The minerals are literally rearranging their atoms just to exist. And all around you, you'd feel this constant, deep, rumbling vibration from seismic waves bouncing around the planet. So we've traveled almost 3,000 kilometers down, and we're coming up on the next major checkpoint, a boundary where everything is about to change drastically. Okay, here we are, depth 2,900 kilometers. We've hit a sharp boundary that scientists call the Gutenberg discontinuity. And instantly, the temperature skyrockets to a blistering 4,000 degrees Celsius. But the pressure, wow. We're talking 1.3 million times the pressure you feel right now. It's just hard to even wrap your head around. We've made it to the outer core. So we're through the solid rock. And now we're in a massive, churning ocean of molten metal. This is the outer core. And it's not just some hot liquid. It is literally the engine that keeps our planet alive. So how does that work? Well, as all this superheated liquid iron swirls around, it's creating huge electrical currents. It basically turns the core of our planet into a giant electromagnet. This whole process is called the dynamo effect, and it's what generates the massive magnetic field that wraps around the entire Earth. Okay, but why should we care about some magnetic field way down there? Well, that field, the magnetosphere, is our planet's invisible force field. Seriously. It protects us from dangerous radiation from the sun, and, this is the big one, it stops the solar wind from just stripping our atmosphere away into space. Without this churning engine deep inside the Earth, life up here on the surface, it just wouldn't be possible. Period. Okay, this is it. We're pushing through that liquid metal ocean, and we're about to arrive at our final destination. The most extreme, the most bizarre, and the most paradoxical place in our planet. We've reached the inner core. And this is where things get really weird. This is the great paradox at the center of the Earth. The temperature here is about 6,000 degrees Celsius. Let that sink in. That's hotter than the surface of the sun. So it's got to be liquid, right? Nope. It's a solid ball of iron and nickel. How is that possible? The pressure. It's an absolutely mind-crushing 3.6 million times the pressure at the surface. It's squeezing those atoms together so tightly that they literally can't melt, no matter how hot it gets. But what if we could get to the very, very center? The physics there would be something else entirely. Gravity would just disappear. Think about it. You'd have the entire mass of the planet pulling on you equally from every single direction. The forces would cancel each other out perfectly. You'd be totally weightless, just floating, suspended right in the heart of our world. So there we have it. We've made it. We've completed this incredible imaginary journey. So what's the takeaway? What does it all mean? Well, for one thing, all that heat we talked about isn't just sitting there. It's constantly, slowly escaping. And that escaping energy is the engine for pretty much all of Earth's geology. It's what powers volcanoes, what causes earthquakes, what literally shoves continents around the globe. If we didn't have that internal fire, Earth would just be a cold, dead rock. And this whole trip wasn't just a journey through space. It was a journey through time. Every single layer we pass through is like a page in Earth's 4.5 billion-year-old history book. That core? It's holding the leftover heat from when the planet was first violently formed. It's like a memory of creation itself. So in the end, a trip like this is about more than just science, isn't it? It's humbling. It's a way to appreciate the incredible power that's constantly working to keep our world alive. To actually be there would be like feeling the living pulse of the Earth itself. It's invisible to us, it's been going on forever, and we absolutely could not live without it. And the wildest part, all of it, this whole world of insane heat, crushing pressure, and incredible power, it's all churning away right now, just a few thousand kilometers beneath where you're sitting. It really makes you wonder, doesn't it? What other amazing secrets is our planet hiding, just under the surface?